In this video, I'm going to help you solve trig equations. I like to think of three different steps whenever I'm solving a trig equation. The first, you always want to think about what quadrant is your angle in? What quadrant does your angle lie? Is it in quadrant 1, 2, 3, or 4? Once you know that, think about what reference angle. What's our reference angle? Which one corresponds with the information that we're given? And then the third thing, is our answer. What is the angle measure? And it's always going to be in standard position. So if we go through these three steps, we should be able to answer and solve a bunch of trig equations. All right. So these are the three steps I'm going to do. Take a moment, write them down if you need to. I'm going to go through some examples. Start off with a pretty basic one here. Trig equations are usually asking you to solve for the angle. So what angle gives us a sine value equivalent to 1? The first thing I'm going to think about is where am I at on my unit circle or my coordinate plane here. If I want a y value that's equal to 1, you can think about the coordinates. You could have 0, 1. You could have, that's about it, right? 0, 1. This would be 1, 0. This would be negative 1, 0. And this would be 0, negative 1. So there's really only one possibility, right? So we are on a quadrantal axis, I guess, right here. So the angle in standard position is right here. What angle does that correspond with? 90 degrees would be our answer. Or if we were asked to put our answer in radians, it would be the equivalent pi over 2. So that's really the most basic one. When you have a quadrantal angle, any one of these four makes that really easy. Now if we had asked for the sine of 0, that might have changed some things. We would have had some more options there, but the sine of an angle that's equal to 1 only happens at this spot right here, 90 degrees or pi over 2. Let's make it a little bit tougher this time. Do another sine. So we want to know what angle corresponds with a sine value of negative square root of 3 over 2. Alright, well let's think about where we could be at. What are the possible coordinates? There's a possible coordinate. There's another possible coordinate. So we got two options. Positive x and a negative y value. So positive x is here, negative y, that would be in quadrant 4. We also have an option where it's a negative x value and a negative y value. Negative x, negative y would be in quadrant 3. Let's sketch these angles out. So there's possibilities. Alright, so we know our location now. Second step would be to think about the reference angles that correspond with these coordinates. So 1/2 and square root of 3 over 2 corresponds with either 60 degrees or pi over 3. So we would have the same reference angle in either location. Alright, so we did step 2. Step 3 would be to find the actual angle in standard position. So this angle measurement right there, this full angle measurement, that would be a third less than 3/3, because that would be 1 pi. So if I am in terms of thirds, 1 pi would be 3/3, and I'm an extra third past that, so my angle must be 4 pi over 3, or 4/3 pi. But I also have a second option. I also have this angle right here, that full angle. And if I want to think about the measurement of that, I would have to think about a full circle being 2 pi, and in terms of thirds, that would be 6/3. That's equivalent to 2 pi. So I'm a third less right here than a full 2 pi. So a third less than 6/3 would be 5/3. And so these are both answers. They both give me a negative y value, or a negative sign value, of the square root of 3/2. So 2 possible answers, 2 angle measurements that would fulfill this equation right here. Alright, let's do another one. This time we're going to have to solve a little bit. This time I'm also going to use x in place of my missing angle, not theta. And then, I forgot to mention this, but a lot of times these sorts of problems, they'll give you the possibilities. Like this right here means in a full circle, in a full rotation, where does this happen? Where is this equation true? And now these interval notations right here may be different. They may only say from 0 up to 1 pi, or from 0 to pi over 2. So they're kind of telling you what quadrants they want you to focus on. So in this video, I'm going to focus on a full rotation every time, just because I want you to see the possibilities that are out there. So when you're solving these equations, take a look in your book or wherever you're getting the problems from and see what interval they want you to focus on. A lot of times it'll be the full circle, and that's what I'll continue doing. Alright, so this equation needs to be simplified just a little bit before we can do the 3 steps that we've been working on. Treat it just like a normal equation. I want to solve for x, but because we have a trig function in front of it, really we're solving for this entire statement or expression right here. Let's get cosine of x all by itself. In order to do that, we follow the same properties we normally would. We're going to undo addition first by subtracting 1. So that leaves behind this. And I'm still trying to get cosine by itself. Now I have to undo this multiplication. Let's divide by 4. So now we finally get to the good stuff. I'm going to reduce -1/2. So now I'm looking for an angle that corresponds with a cosine value of -1/2. So if we think about our options here, that's a possibility, and this would be a possibility. So a positive y value could correspond with this, or a negative y value could also correspond with this. Let's think about our locations here. Where are we at? Negative x, positive y would be in quadrant 2. Negative x, negative y would be in quadrant 3. So there's our locations. Let's think about our reference angle. Corresponds with a 1/2 and square root of 3/2. That would be 60 degrees, or pi over 3. And this one would be the same, just in a different location. I could also be talking about this in terms of degrees, but because this interval is described in radians, I'm going to keep it in terms of radians. If this had said 360 degrees right here, I could have been talking about it in degrees, but hopefully you can figure that out. So we want the angle in standard position here that gets us to that spot. Well, if this were 3/3, if I went all the way over, that would be 3/3, so I'm a third less than that. So I must be at 2/3 pi there. And then down here, this angle in standard position is a third more than 3/3, so I'm at 4/3 pi. Alright, so there's our two answers. If we take the cosine of this in radians, we should get negative 0.5. If we take the cosine of this measurement in radians, we should also get negative 0.5. So there are two possible answers, two solutions to this equation. Alright, the last one I'm going to do is tangent. Tangent's probably the trickiest of them. But one thing that really helps is if you know your tangent values for each of your standard intervals here. If you know the form in which tangent takes for each of these angle measurements, it makes solving tangent equations a lot easier, and just working with tangent in general is a lot easier. If you know that the tangent of 30 degrees or pi over 6 is this form, or it could also be written if we were to rationalize in this form, being able to recognize that as the tangent of 30 is really helpful. Tangent of 45 is always going to be 1, and the tangent of 60 or pi over 3 is always going to be just the square root of 3. And so if you can recognize these, it makes it so much better. Let's try a tangent equation. So again, we're going to be working with this interval. So we're going to be working in radians. I'm going to simplify my equation. So I'm going to add 1 to both sides. And then I'm going to divide and undo that multiplication right there. Divide both sides by that. Square root of 3. So now, this is the equation that I'm really finding the solution for. So again, because I know that this corresponds with 30 degrees or pi over 6, it makes my life a lot easier. Because I know that my reference angles are always going to be in these two quadrants. And the reason why I know that, I'm going to show you another nice little trick here. If you know what functions are positive and negative in each quadrant, it also is quite helpful. So I know that all of my functions are positive here. Only sine functions are positive in this quadrant. Tangent functions are positive in this quadrant. And cosine functions are positive in this last quadrant. So I know that if I have a positive tangent ratio, I have to be in this first quadrant or this third quadrant. And so my reference angle here is going to be pi over 6. Same thing over here. And I want the angle in standard position. Well, that would be equal to the reference angle, so pi over 6 is one answer. There's that option. And then this angle in standard position. Well, if I know that 1 pi is 6/6, I got an extra 6 more than that, so we're at 7 pi 6, or 7/6 pi. So, tangent is probably the trickiest of them all. But again, if you can recognize the forms of your tangent ratios for any of your intervals, it makes it a lot easier. And then we just follow those 3 easy steps. Think about what quadrant your angle is lying in. Think about what your reference angle is. And then find the measurement of that angle in standard position there. And that should get you there. Alright. Also knowing which functions are positive in each quadrant is also really helpful as you solve these. You can come up with your own mnemonic device or memorization technique. Some people say all students take calculus, or all students top of the class, something like that. I mean, come up with your own just to memorize that. It makes it a lot easier to work with functions if you know that they're positive or negative depending on where you're sitting at. Alright, so good luck solving trig equations.